Hey everyone, and welcome back for another deep dive. Today we're taking a journey through our solar system, focusing on the inner planets, Mercury, Venus, Earth, and Mars. These rocky worlds huddled close to the sun are like a history book of planetary formation, each with its own unique story to tell. Just imagine standing on a planet where the sun just scorches the ground to 800 degrees Fahrenheit during the day, but then plummets to negative 290 degrees Fahrenheit at night.
Wow.
That's Mercury. And that's just the beginning of our adventure.
It is fascinating how diverse these inner planets are despite their similar composition.
Right. So before we jump into exploring each planet, can you give us a quick rundown of what actually makes a planet an inner planet?
Absolutely. Think of it this way. The inner planets, also called terrestrial planets, are the ones closest to the sun. They're primarily made of rock and metal, relatively small, and have few or no moons. This is in stark contrast to the outer planets, the gas giants, which are much larger, composed mostly of gases, and have numerous moons.
Okay, that makes sense. So let's start with Mercury, the closest to the sun. You mentioned the crazy temperature swings. What causes that? It's not like Earth experiences anything close to that kind of extreme.
You're right. Earth's atmosphere helps regulate our temperature, but Mercury has practically no atmosphere to speak of. So during the day, the sun's radiation bakes the surface, but at night, all that heat escapes into space, leading to those wild temperature swings.
Wow, so it's like stepping out of a furnace and into a freezer. But Mercury is more than just extreme temperatures, right? I've seen pictures and it's covered in craters.
Yeah.
Like a cosmic pincushion.
Exactly. And those craters tell a story. Because of its lack of atmosphere, there's nothing to burn up incoming meteors. They slam right into the surface, leaving behind those scars that have persisted for billions of years. It's a glimpse into the early solar system's chaotic bombardment phase.
Billions of years. So we're seeing evidence of events that happened when the solar system was still forming.
That's incredible. Speaking of ancient history, I remember reading that Mercury has a surprisingly large iron core. It's true. Mercury's core makes up about 85% of its radius, which is much larger proportionally than Earth's core. It's a bit of a mystery how such a small planet ended up with such a massive core.
Okay, so a small planet with a giant iron heart, extreme temperatures, and a surface pockmarked with craters. Mercury definitely seems to pack a punch. But what about its neighbor Venus? I've heard it called Earth's twin, but something tells me it's not exactly a friendly twin.
You could say that. Venus is similar to Earth in size and density, which is why it gets that twin nickname. However, the similarities end there. Venus is shrouded in a thick, toxic atmosphere, mostly carbon dioxide.
And that's where the whole evil twin idea comes in, right?
Yeah.
What's so bad about a carbon dioxide atmosphere?
Well, on Venus, the CO2 creates a runaway greenhouse effect. Think of it like a car parked in the sun with the windows rolled up. The sunlight gets in, but the heat can't escape. On Venus, the thick atmosphere traps heat, making it the hottest planet in our solar system, even hotter than Mercury.
Wow, hotter than Mercury, even though it's farther away from the sun. That's crazy.
It is. The average surface temperature on Venus is about 900 degrees Fahrenheit, hot enough to melt lead. It's definitely not a place you'd want to visit.
No kidding. Okay, so we've got the scorching heat. But what else is strange about Venus?
Well, how about this? A day on Venus is longer than its year.
Wait, what? How is that even possible?
It's because Venus rotates incredibly slowly, and it spins backward compared to most other planets. This retrograde rotation, combined with its slow spin, means that a day on Venus lasts longer than it takes for the planet to orbit the sun.
So not only is it scorching hot, but it also spins backward, and its days are longer than its years. Venus is definitely living up to that evil twin reputation. But I've heard there's more to the story. What about those recent discoveries about potential volcanic activity?
That's right. Recent observations suggest there might be active volcanoes on Venus, which is fascinating because volcanic eruptions could be a factor in the planet's intense heat and its thick, toxic atmosphere.
Active volcanoes. We're talking eruptions and lava flows.
Possibly. It's still a subject of debate. But the evidence is mounting. We're learning more about Venus all the time, and these recent discoveries just highlight how dynamic and complex our planetary neighbor truly is.
It sounds like Venus is a place of extremes. Scorching heat, a backward spin, a toxic atmosphere, and now maybe even active volcanoes. Definitely not on my list of vacation destinations.
Yeah.
Which brings us to a planet much more hospitable to life.
Yeah.
Our own Earth.
Earth. The Goldilocks planet. Not too hot, not too cold, just right for life as we know it.
And thank goodness for that. But what exactly makes Earth so special? We all know we have liquid water, a breathable atmosphere, a magnetic field. But what's the bigger picture here?
All of those things are absolutely critical, and they work together to create a delicate balance that sustains life. Our atmosphere, composed mainly of nitrogen and oxygen, is essential for us to breathe, and it also acts like a shield, filtering out harmful radiation from the sun.
Right, and our magnetic field,
Uh,
which is generated by Earth's molten iron core, helps protect our atmosphere from being stripped away by solar wind. It's like having a giant force field around our planet.
Exactly, and let's not forget the dynamic nature of Earth's surface. The continents are constantly shifting due to plate tectonics. We have active volcanoes that shape the landscape, and erosion and weathering constantly reshape the surface. All of these processes play a role in regulating our climate and making Earth the unique and vibrant planet we call home.
It's amazing to think our planet is constantly changing, even if we don't notice it in our daily lives. All these complex systems working together to make life possible. It really makes you appreciate just how special Earth is, especially compared to a planet like Venus.
You're right, the contrast is striking. And speaking of contrast, let's move on to our final destination on this inner planet tour, Mars, the red planet.
Ah, Mars, the planet that has captivated human imagination for centuries, and for a good reason. There's that reddish hue from the iron oxide,
Yeah.
basically rust all over the surface. But what I find truly fascinating is that Mars wasn't always the cold, dry desert we see today. There's evidence it once had flowing water,
Mm.
just like Earth.
Absolutely. We see signs of it everywhere. Dried up riverbeds, ancient lake basins, and even evidence of massive floods. It's a stark reminder that Mars wasn't always the way it is now.
So what happened? Where did all that water go?
That's a question scientists are still trying to answer, and it's a crucial piece of the Martian puzzle. The leading theory is that Mars gradually lost its atmosphere, probably due to a combination of factors, like solar wind stripping it away, and its weaker gravity not being able to hold on to it. Without the atmosphere to provide pressure and warmth, the liquid water either froze or escaped into space.
It's amazing to think of Mars as a planet with rivers and lakes, maybe even oceans,
Yeah.
billions of years ago. But that brings up the big question. If Mars had liquid water, could it have also supported life?
That's the million-dollar question, isn't it? And it's why missions like Perseverance are so exciting. Perseverance is actively searching for signs of past life, whether it's fossilized microbes or chemical signatures in the rocks and soil.
Imagine if we find definitive proof that life existed on another planet. It would revolutionize our understanding of life in the universe. It would be like...
Like finding another branch on the tree of life.
Exactly.
Okay.
So we've journeyed from the scorching surface of Mercury, the volcanic plains of Venus, marveled at the life-sustaining beauty of Earth, and pondered the mysteries of Mars' watery past. It's been quite a tour. But before we go any further, let's take a moment to compare these fascinating planets side by side. I think it would be helpful to get a clearer picture of how they stack up.
That's a great idea. It's always helpful to see the big picture. So let's start with size. Mercury is the smallest, only about 38% the size of Earth. Venus is very close in size to Earth, about 95%, which is why it's often called Earth's twin. Earth, of course, is our reference point.
Yeah.
And then we have Mars, which is about half the size of Earth.
Okay, so a pretty big range in size, even among these inner planets. What about their atmospheres? We've talked about how wildly different they are.
Right. Mercury has essentially no atmosphere to speak of. Venus, on the other hand, has an incredibly thick atmosphere, composed mainly of carbon dioxide, which is what leads to that runaway greenhouse effect. Earth has a balanced atmosphere with just the right mix of nitrogen and oxygen to support life. And Mars has a very thin atmosphere, mostly carbon dioxide. That's why it's so cold and dry.
So the atmospheres are all over the map. What about surface temperatures?
Well, we've already talked about the extremes on Mercury and the scorching heat of Venus. Earth, of course, has a comfortable average temperature thanks to its atmosphere and distance from the sun. And Mars is quite chilly, with temperatures that can plummet to negative 195 degrees Fahrenheit.
And what about one of the most important ingredients for life as we know it, water?
Oh, yes, water. Mercury and Venus have no liquid water on their surfaces. Earth, of course, is teeming with water, with oceans covering about 71% of its surface. And while Mars is dry today, we see strong evidence of a watery past, which is why it's such a focus of current exploration efforts.
That makes sense. And finally, how do these planets compare when it comes to moons?
Well, Mercury and Venus has no moons at all. Earth has its faithful companion, the moon, which plays a significant role in stabilizing our planet's rotation and tides. And Mars has two small moons, Phobos and Deimos, which are probably captured asteroids.
Okay, so we've got this diverse group of planets, all orbiting relatively close to the sun, but each with its own unique story, its own set of characteristics, and its own mysteries waiting to be unraveled. It's incredible how much variation we see even within our own little corner of the galaxy.
It really highlights the incredible diversity of worlds that can exist. And studying these inner planets helps us appreciate just how special and fragile our own planet is, as well as providing clues about the conditions necessary for life to arise elsewhere.
It's like a cosmic laboratory right in our backyard.
Exactly. And speaking of labs, I think we need to take a break and head to our own metaphorical lab. But we'll be right back to dive even deeper into these fascinating worlds. It's truly remarkable how much we've learned about our celestial neighbors, yet how much remains shrouded in mystery.
It's like we've only just scratched the surface of these planets, and each new discovery opens up a whole new set of questions.
Exactly. And it's those unanswered questions that drive us to explore further. Take Venus, for example. We once thought it might be a lush tropical paradise, but as we've learned more, it's become clear that it's a world of intense extremes, and those extremes can teach us valuable lessons about our own planet.
It's almost like a cautionary tale, isn't it? Seeing how Venus's atmosphere became so dense and toxic with that runaway greenhouse effect really underscores the importance of understanding and protecting our own atmosphere here on Earth.
Absolutely. Studying Venus helps us see what can happen when a planet's climate goes off the rails. It's a powerful reminder of the interconnectedness of planetary systems and the delicate balance that's needed to sustain life.
It makes you wonder if we could turn back the clock.
Right.
Could we have prevented Venus from becoming the scorching inferno it is today?
That's a question that planetary scientists are still grappling with. We don't fully understand what triggered the runaway greenhouse effect on Venus, or if it was even preventable. Was it a massive volcanic eruption, or a gradual process driven by subtle changes in the planet's orbit?
It's like a cosmic mystery waiting to be solved.
Yeah.
And speaking of mysteries, let's shift our focus to Mars. This is the planet that has captivated our collective imagination for centuries, fueled by dreams of finding evidence of life beyond Earth.
And those dreams are not unfounded. Mars holds the tantalizing possibility of past life, the evidence of ancient water flows, the polar ice caps, the possibility of finding fossilized microbes, or even evidence of current subsurface life. It's all incredibly exciting.
I remember reading about those Martian riverbeds, those dried-up lake basins, and trying to picture what it must have been like billions of years ago, when liquid water flowed freely on Mars.
Imagine standing on the banks of an ancient Martian river, watching the water flow by. It's a scene that's both familiar and alien, and it sparks so many questions. What was the Martian climate like back then? How long did those lakes and rivers persist? And most importantly, did life ever emerge in those Martian waters?
It's incredible to think that evidence of ancient life might be right there just waiting to be discovered, and we're actively searching for it. The rovers we've sent to Mars, like Curiosity and Perseverance, are doing an incredible job of piecing together the clues, analyzing the rocks, searching for those telltale signs of past life.
It's like having robotic detectives on Mars, working tirelessly to uncover the secrets of the red planet's past, and they're sending back stunning images of the Martian landscape, those red plains, those towering mountains, those deep canyons. It's like visiting another world from the comfort of our own homes.
It's true. Those images are breathtaking. But even with all the amazing data we're gathering, Mars remains a planet of mysteries. Why did it lose its atmosphere and water? Could life still exist in some form beneath the surface? Are there underground reservoirs of water? Or even pockets of microbial life clinging to existence in the Martian subsurface?
These are the questions that keep planetary scientists up at night. They're the driving force behind our continued exploration of Mars. Each new mission, each new discovery, brings us one step closer to understanding this enigmatic planet.
It's like peeling back the layers of an onion, only with every layer we peel back, we find more layers, more complexity, more questions.
Exactly, and that's the beauty of scientific exploration. It's a journey into the unknown, a process of constantly refining our understanding as we gather more information. It's not about finding all the answers. It's about embracing the questions and letting them guide us toward new discoveries.
It reminds me of that quote by Marie Curie, "Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less."
Beautifully put. And speaking of understanding more, we spent a lot of time talking about Venus and Mars, but let's not forget about Mercury, a planet that's often overlooked but holds its own set of intriguing puzzles.
You're right. Mercury is a bit of an enigma. It's the smallest planet in our solar system, and it orbits so close to the sun. But it's also a world of stark contrasts. with its scorching days and frigid nights. And what about that giant iron core? How did such a small planet end up with such a massive core?
That's a great question, and it's one that scientists are still debating. Some theories suggest that a giant impact early in its formation could have stripped away Mercury's outer layers, leaving behind the dense core. Others propose that the intense solar radiation could have played a role in vaporizing some of its outer material.
It's amazing to think about the forces that shaped these planets billions of years ago. It's like trying to piece together a cosmic puzzle, and each new discovery gives us another clue.
Exactly. And Mercury's proximity to the sun also makes it a unique laboratory for studying the effects of solar radiation and gravity on a planetary body.
I remember learning about Mercury's unusual rotation, how it spins 3 times on its axis for every 2 orbits around the sun. It's a fascinating dance.
It is. And that unusual rotation, combined with its elliptical orbit, creates a phenomenon where the sun appears to move backward in the sky at certain times. Imagine witnessing that from the surface of Mercury.
It would be mind-bending. And it highlights the fact that even within our own solar system, there are worlds that operate according to rules that seem strange and counterintuitive to us.
Absolutely. And that's what makes exploring the inner planets so rewarding. It's a constant process of expanding our understanding of what's possible, of challenging our assumptions about how planets form and evolve.
It's a reminder that we still have so much to learn, even about our own celestial neighborhood.
Absolutely. And that sense of wonder, that drive to uncover the secrets of the universe, is what keeps us pushing forward, launching new missions, and probing deeper into the mysteries of these fascinating worlds.
Well said. And speaking of pushing forward, I think it's time for us to push forward with our exploration of these inner planets. We've covered a lot of ground already, but there's so much more to discover. We've talked about the scorching heat of Venus, the ancient riverbeds of Mars, and the mind-bending orbit of Mercury. It's amazing how each of these inner planets tells a different story about planetary evolution.
It's true. They're like different chapters in the same book, each offering a unique perspective on the processes that shaped our solar system.
And speaking of perspectives, I think one of the most valuable things about studying the inner planets is that it helps us see our own planet Earth in a new light.
You're absolutely right. When we compare Earth to its neighbors, it really highlights just how special and fragile our planet is. It's a delicate oasis in the vastness of space, with a unique set of conditions that allow life to flourish.
It's easy to take Earth for granted, but when you consider the scorching heat of Venus or the thin, frigid atmosphere of Mars, it makes you appreciate what we have here.
Absolutely. And studying those other planets can also teach us valuable lessons about how to protect our own. Venus, with its runaway greenhouse effect, serves as a stark warning about the dangers of unchecked climate change.
It's a reminder that our actions have consequences and that we have a responsibility to be good stewards of our planet.
And studying Mars, with its evidence of past liquid water and the possibility of past life, reminds us that life, even in its simplest forms, is a precious and potentially rare phenomenon in the universe.
It makes you wonder if we're alone in the universe, or if there are other planets out there teeming with life waiting to be discovered.
That's the ultimate question, isn't it? And the inner planets provide a unique perspective on that question. If life could emerge on Mars, even in the distant past, it suggests that life might be more common than we think. But if it never emerged on Venus, despite its early similarities to Earth, it makes you wonder what the true odds are.
It's a cosmic mystery that we're still trying to unravel.
Exactly. And each new mission, each new discovery, brings us one step closer to understanding the conditions necessary for life to arise and the vast possibilities that exist in the universe.
Speaking of missions, there are some truly exciting ones planned for the future of inner planet exploration. NASA's Da Vinci I+ mission will dive deep into Venus's atmosphere, trying to unlock the secrets of its runaway greenhouse effect. And then there's the ambitious goal of sending humans to Mars, which would be a giant leap forward in our understanding of the red planet.
And let's not forget the potential for future missions to Mercury, perhaps even a lander that could study its surface in detail and search for signs of water ice in its permanently shadowed craters.
It's an exciting time to be following planetary science. There are so many mysteries waiting to be unraveled, and the discoveries we make could revolutionize our understanding of the solar system and our place in the universe.
It's a journey of exploration and discovery that we can all be a part of. So keep looking up, keep asking questions, and never lose that sense of wonder and awe.
Well said. So, as we wrap up this deep dive into the inner planets, I want to leave our listeners with this thought. These planets are more than just celestial objects. They're worlds with rich histories, complex processes, and the potential to teach us profound lessons about our own planet and the possibilities for life beyond Earth.
Absolutely. And the more we learn about these other worlds, the more we appreciate the delicate balance that makes life possible on our own.
And if you want to continue exploring the cosmos with us, be sure to follow and subscribe to Cosmos in a Pod. And check out our YouTube channel for stunning visuals and in-depth explorations of all things space.
We'll be back soon with another deep dive into the wonders of the universe.